Hello student, myself Shweta Kulkarni from Physics Department, JSS College. Today we discuss the continuation part of the semiconductor. In this session, discussion points are half-wave rectifier and full-wave rectifier, additional part, filter circuit. Another special type of the diode is Zener diode. It's a special characteristic. Zener diode acts as a voltage regulator. Before this, in the previous session, we discussed PN junction diode act as a forward bias and reverse bias. Forward bias means P side is connected to positive terminal of the battery, N side connected to negative terminal of the battery. Reverse bias, P side is connected to negative terminal of the battery, N side is connected to positive terminal of the battery. Now, in today's point, application of the junction diode as a rectifier. First point, rectification. The process of converting a alternating current AC into direct current DC is known as rectification. The AC signal na DC signal nagi convert madodukka rectification antara. Then rectifier. The device used to convert AC into DC is called rectifier. Which device we used for the conversion of alternating current into direct current, that device is known as rectifier. First point, half-wave rectifier. As the name itself indicates, half-wave rectifier means only half of the wave is get rectified, means only half of the AC is converted into DC form. As the definition what it says, it is a type of a field rectifier that only allows one half cycle of an AC voltage waveform to passes through it, blocking the other half cycle. Means if AC means two directional, positive and negative, only half of the cycle is allowed and it blocks the another half, means only positive cycle is allowed, not of the negative cycle. Negative cycle is not allowed. For the name itself, half wave rectifier. It's a important one, 5-mark question. Construction and working of the half-wave rectifier with the help of a waveform diagram. 5-mark, either they ask half-wave or full-wave rectifier. It's a diagram and a waveform representation. First, its working principle. The junction diode offer a low resistance path when forward bias and high resistance when reverse bias. As we already know, resistance is opposition for the flow of the charge carrier. Forward bias means already current is high. Current high, why we get a high current? For the offers of a low resistance. If a diode under the reverse bias condition, current is less due to high resistance offer. Next, it's a construction part. Construction means what are the components are there in the half-wave rectifier. The AC supply is fed across the primary coil P of a step-down transformer. The secondary coil S of a transformer is connected to the junction diode and load resistance RL. The output DC voltage is obtained. Primary coil, secondary coil, step down transformer, diode, load resistance. How they are connected. Primary and secondary coil differentiate on the base of number of the windings. For the primary, more number of the woundings. For the secondary, less number of the woundings. Why they prefer the step down transformer means for the conversion of AC to DC, step down is very helpful, not for the step up. This secondary coil is connected to diode P side and to the load resistance RL. Primary coil, secondary coil ends are connected to the diode P side and for the load resistance. And one thing we observe in the waveform, we get the pulsation for the positive half cycles only. It clearly clarifies half of the wave is to be rectified. Now move to its working process. The secondary of a transformer supplies the desired AC voltage terminal across A and B. When the voltage at point A is positive, diode is forward bias and it conduct. When A is a negative, diode is a reverse bias and it does not conduct. The reverse saturation current of the diode is negligible, can be considered equal to 0 for a practical purpose. Therefore, the positive half cycle of AC is conducted through RL. We get the output voltage, whereas no current in the negative half cycle. This process is continue for the next one. Now, one by one. This is of the input pulsation, positive, negative. When the positive pulse enters the secondary coil terminal A and B, for the positive half cycle, point A become positive, point B become negative, and according to diode, positive, negative. P side connected to positive, N side connected to negative. What is a forward bias condition? P side of the diode is connected to positive, N side is connected to negative. Same thing it happen. P side connected to positive, N side connected to negative through load resistance. So it clarified that diode become forward bias and it get conducted. Same thing in the reverse manner for the negative half cycle. When this negative half cycle reaches the secondary coil, point A become negative, point B become positive. A, B, and of the diode. Point A become diode negative means P terminal connected to negative. Point B is positive means N terminal is connected to positive. It is a condition for the reverse bias. Reverse bias condition, what it says? P side connected to negative, N side connected to positive. Same, P side connected to negative, N side connected to positive. It shows diode is under the reverse bias condition. So we are not getting any current for the reverse bias. One question it may arise. In the reverse bias, minority charge carriers are moving means even though we are not getting any pulsation for the reverse for the negative half cycle, because in the reverse bias current is generated, it is very small, is nearly equivalent to 0. So we neglect that generated current for our practical purpose. It clarified that only positive cycles are to be conducted with the help of the diode under forward bias condition. Once again, positive cycle secondary coil ಬಂದಮೇಲೆ ಪಾಯಿಂಟ್ ಎ ಪಾಸಿಟಿವ್ ಪಾಯಿಂಟ್ ಬಿ ನೆಗೆಟಿವ್ ಆಗಿ ಡಯೋಡ್ ಡಿ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ಆಗಿ ಕಂಡಕ್ಟಿವಿಟಿ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ನೆಗೆಟಿವ್ ಪಲ್ಸೇಷನ್ ಸೆಕೆಂಡರಿ ಕಾಯಿಲಿಗೆ ಬಂದರೆ ಪಾಯಿಂಟ್ ಎ ನೆಗೆಟಿವ್ ಆಯ್ತು, ಪಾಯಿಂಟ್ ಬಿ ಪಾಸಿಟಿವ್ ಆಯ್ತು. ಡಯೋಡ್ ರಿವರ್ಸ್ ಬಯಾಸ್ ಆಗಿರಂದ ನೋ ಕರೆಂಟ್. ಸೊ ಓನ್ಲಿ ಪಾಸಿಟಿವ್ ಪಲ್ಸಸ್ ಆರ್ conducted, not of the negative pulses. Due to this, we have one drawback of half-wave rectifier. What is that drawback? First thing, observe this output waveform pulse. Is it in the pure DC form? No. What is the waveform of a pure DC? It is a constant one, steady one. But at this stage it is not steady, it is in the pulsating form. So one drawback of this, we did not get a full DC for an AC supply, only half wave is conducted. ಅಂದ್ರೆ ಫುಲ್ ಡಿ ಸಿ ಫಾರ್ಮ್ ಬಂದಿಲ್ಲ, ಎ ಸಿ ಫಾರ್ಮ್ ಕಂಪ್ಲೀಟ್ಲಿ ಇಲ್ಲದೆ ಇರೋದಕ್ಕೆ ಅದು ಒಂದು ಡ್ರಾಬ್ಯಾಕ್ ಆಯಿತು.